Hello, hello. Welcome to a new stream. Yep, we were shooting stuff. Lots of issues. We figured them out. The hardware issues I already fixed them last time, so we printed some new stuff. Blah blah blah. But then we had some software problems that we couldn't quite finish at the near the end of the stream because the place we're at is it closes at 10 p.m. So we had to like make a run for it. So, but yeah, we fixed those problems, and this is what we have now. Right now, we're just gonna assemble this card because the software we already fixed it. So now we're just gonna be assembling.
Yeah, as you can see also here's the hardware of last time. I mean, we're not going to disassemble this because it worked really well.
Yeah.
So maybe also one thing maybe we can add in the future is maybe elongate this one, because now this is the bumper, but the bumper is, I mean, it could maybe in the future
it's missing.
Yeah, it's missing something.
You know,
yeah, so I think
it's missing.
We did also bump in something already today, and
it worked.
It worked,
but it got bent out of shape.
Yeah.
But it
actually,
actually,
no explosions, so.
it did exactly what it performed the way I expected it to perform, which is actually pretty good. Also, the bending of it takes away the energy of the crash, so you know.
Yeah, it's a what is it, like a crash zone?
Crash zone? Well, I don't know what you call it in English actually.
Yeah.
I never looked it up in English, but whatever.
Yeah.
Yeah. So it actually looked pretty good.
Yeah. Do you want to maybe explain what you can see here, and then I will just talk about new things?
Well, this is a frame we made out of these metal strips that we cut. We bought this huge roll. It was 30 kilograms of it, and it's we built this cutter for it out of wood, and then we just cut these strips to size, and that way we build our own chassis for different things, or well, actually anything you want. But right now we're doing the RC car. It pretty much works like Meccano, if you know those old toys, like builder toys. It was just basically metal strips. You just screw them together. Oh, sorry. That's what this is.
A little bit closer.
Yeah. So we just screwed together a chassis for this RC car. And then we added some 3D printed parts. This is the platform for the Raspberry Pi. It's going to set on here. The steering mechanism designed and 3D printed. Servo here. This is really like duct taped, but that's because the holder is broken.
Yeah.
So
it's also just only fixed on 2 points. So even if it would have been whole, I mean. It moves
right
too
there.
much because it has, of course, to steer, and it just wobbles the whole time.
So,
it's
that's the next thing I'm gonna be redesigning in the 3D printer. Oh, did you add a bracing?
Yeah. It really helped.
Did you add that today?
Yeah, I did that.
Oh, he added a metal strip, a thin one there.
Yeah, to stabilize the servo. It really helps.
Yeah, and the rear drive unit. It's 3D printed with one huge ass cog on it, and the big ass motor.
So also like the motor spins very fast, so we need to slow down the rotation to get more torque.
Yeah, so that's why we have this big gear.
So this one rotates 3 times slower than the motor.
No, that's different now. No. It's this one has 10 teeth. This one has 70, so it's 6.
Really?
1 to 6. Yeah.
Really?
It's 1 to 6 now.
Oh damn.
Yeah.
Really? So we like 1 rotation. Really?
Yeah.
So like 6 rotations. Oh wow.
Yeah, it's 1 to 6. So
that's really nice.
Yeah, it works really well.
More torque.
Yeah, it's more torque and less weird shit. So this is all 3D printed. This, like the very first time we tried it, this part broke,
Yeah.
So we did that one, and this time with 100% infill on the 3D printer. The 3D printer we have just does standard 20% infill, unless you change the settings. So I just change the settings to 100% infill it, because then it's like the strongest it can be. Because it like totally broke this part right there. Last time we just one crash, so yeah, fix that like that. Same thing happened to these, because this is like a metal rod that we just put through some ball bearings. You can kind of see the bearings. Kind of figure out how to rotate this thing. Yeah, there you can see the bearings here, right there. Whoop, right there. Metal rod goes in there, and it's all screwed together. But these parts are also 3D printed, so that allows us to attach the wheels to the metal rod. So yeah, it's a mix of 3D print and like just sawed off, hacksawed parts, metal strips.
Yeah, and 2 motors, of course. The big motor.
And 2 motors, yeah.
This is one, of course, to move, and this one is just for the steering.
Yeah. So
this is a servo, and this is a DC motor.
Yeah. So now we're just gonna
add the electronics. Let's just introduce the electronics. Let's start with this one. I think a lot of you guys probably know it. It's a Raspberry Pi.
Yeah.
It's like, what is it? 35 euros or something? 40 euros?
Something like that.
So
it's pretty cheap.
Yeah. So it's like a microcomputer. So it runs Linux. So it's a standard Raspberry Pi Linux distribution. It's a Raspberry Pi 3.
Hello, Siren.
By the way. So this Raspberry Pi, this is, let's say, the brain of the car. Then we have, of course, to power the Raspberry Pi. Maybe you can also, I know at least, yeah. So this is the battery. So it's a, it was a power bank, but now it's disassembled to power just the Raspberry Pi.
Yeah.
The reason why we also designated this power bank for the Raspberry Pi is because one of the 2 USB ports is broken. So now it is 1 port, and I mean it works really well for Raspberry Pi. We only need 1 port anyways. Then we have for the big motor, we have an electronic circuit controller, a ESC for short. So it's meant to power big motors. So the reason why we need this is because we have to allow the power from a big energy source to go to the motor, but the Raspberry Pi cannot handle that power, that lot of power. So it needs a, let's say, a very big electronic switch. It's just actually like a switch you have at home, but instead of using your finger to flip the switch, it's like electronic. So the Raspberry Pi say go on or go off. So this is how that one works. Let's put it over there. And then to power the big motor, we have a very big energy block. It's pretty expensive. I think it's the most expensive part of the whole.
Really, how much is that?
I think it's like 50 or 60 euros.
Oh yeah.
So it's this is the most expensive part, the battery.
Yeah, all this stuff is pretty cheap. I mean, the 3D printed parts is like cents, pretty much. When you calculate how much filament goes into it. Yeah. If you have like you buy the filament per the one we have was 750 grams that we bought, and we paid about 30 euros for the whole 750 grams. And then when like printing out one part is like, I don't know, 20 grams. It's really low. So it's like you're talking about cents, really. And then like these metal strips. I mean, the whole thing. We bought this huge roll of metal strips for like 30 euros or something. So and then we cut out these strips, and I mean the roll is what, 35 meters of metal, and this is, up to now, this is all we cut out of it. So divide the 30. So it's about like a euro per meter, and we didn't even cut a meter, so that's pretty cheap. Yeah. And then
maybe also the servo motor is like 3 euros or something, or 4. It's really cheap one. This one is pretty pricey. I think 30 euros or 35. So and the Raspberry Pi is also like 30 or 40 euros.
Yeah, I mean, we're still looking at like more than 100 euros worth of stuff.
Yeah, for sure.
But still, to like get to this point, this point, it's not that expensive.
Except the motor.
Except the motor. The big motor is the most expensive part. But of course, I mean, you do need a 3D printer.
Yeah.
You know, that's the thing, and that's really expensive.
Or you can of course carve it out of wood.
You could carve it out of wood if you want. If you could. Or you can also like order parts. You know, like order 3D printed parts. You can do that.
Yeah.
That's a thing.
From Makerspace or something. I was called Shapeway.
Shapeways, you could do that. Yeah. Or just go to some store. I mean, there's a couple of them in Rotterdam.
Yeah.
That where you can just like hand in a file and they print it for you.
Yeah.
Then you have that, so you could do that. So you don't have to buy a 3D printer, but still, it's a pretty cheap actually. When you build the car, and then the other stuff, of course, it gets more expensive.
Yeah.
Like that, but the individual parts aren't that bad.
No, and also the last part, which is this servo motor head. I think it's possible to just control 2 servo motors with Raspberry Pi. I googled it today, but I actually only used it to only power one of the I used the Raspberry Pi to power or to control the ESC, but it can also actually control the servo motor, I think. But I just only use it for that one to now. So I will use this one to power the servo in front. But I think you can also just go without this one. But I have to figure it out.
Yeah,
But
we
for now it's fine.
at first we tried to. Remember, we had the frequency problem.
Yeah.
We tried to power the rear motor and
The
servo on the same head,
Yeah.
but that doesn't work. One problem is because the head only has max like 1 amp or something like that. The maximum amps it can feed.
So
feed it.
So first I tried to So first I tried to power this motor with this. Was it this head? No, it was another head.
Well,
another
but
head.
it basically
It's something like this, but it was a different one.
Yeah.
But so that one only could indeed. It had a maximum of 1 amp or something, 1.5 amp.
Yeah, and the motor it needs about like 13 or something like that for continuous drive.
This one,
the motor can also do what do you call that? Some kind of, I forgot the word. It's like a sprint or whatever, where it suddenly pulls like 110 amps.
Yeah,
the motor can do that.
Yeah.
For like
boost,
5 boost. Yeah, for like 5 seconds.
We had 10 seconds needed. So this one.
So if you do that on this head, it's gonna blow it up.
Yeah, that's a cooler, so it can participate heat for a few seconds, and you can boost till 110 amps, which is a lot.
Yeah. So if you're gonna boost like that. On this part, you're gonna blow it up. It's gonna fry.
It can handle only 1.5 amp. This can go to 110, so it's almost 10 times as high.
Yeah, exactly.
100 times as high almost.
Yeah, it's
like
crazy.
80,
it's
80,
crazy.
yeah.
It's crazy. So
But,
but last time we solved that problem by making our own crazy relay with a servo.
Yeah, I can also show that one.
With a servo. There it is, right there on the box there.
Yeah. So first we did not have that one, so I made my own Frankenstein's electronics. So instead of using this one, I made my own, which are just 3 switches, which all 3 can handle separately 5 amps. So 3 of them can handle 15 amps. And when I have one servo motor, and it had a wire attached, so I could pull the wire to flip the switches. It's really, really,
It's a crazy idea, but it
really worked. But the switching is not that good, and you can only go forwards.
And at max power.
Yeah.
Total like.
Yeah.
Max.
Almost no control.
No control. It's crazy. If you watch one of our like 2 streams ago, we did a test of it. The thing, it just blasted, and it just crashed because we had almost no control at all. It just boom. Bolted.
We crashed a lot of.
But this time we have more control.
Yeah.
It's good. So I guess that's it for parts, right?
Yeah, and then wires, a lot of wires.
Yeah, a lot of wires. So I guess let's start.
Let's start assembling.
Putting it on. Yeah.
This one is of course the motherboard. Maybe we have to add the brains before the other things.
Yeah, sure.
I don't know. Well, I think this one goes over there.
Should I go put this on full screen or leave us on?
I don't
leave
know.
us
Maybe
like
they
that?
like also to see another view. Maybe they
Yeah.
like the change.
Let me see if anybody's. Oh, we got a. You can let others 3D print parts for you.
Yeah, but you still have to know
So
modeling.
you need to know Yeah, you need to know 3D model.
Yeah.
Well, unless you can you need to build the model itself. That's what I do. I build the models. I use Blender for it. I mean, I can show it. I can show you right now. Here, go to Blender. If you can see here, I have it's a big mess, but I basically. Here's basically exactly the model we have. Let me get out of this mode. Yeah, there you go. Deselect. So this is basically the wheel right here. This is the wheel, and this is the big bar, and this is the where the wheels are attached to, and this is the what do you call it? The big gear. Here's a small gear. Here's the motor. You know, this is the model I used. What I made for 3D printing, you know. Also, it's a big mess. Don't pay too much attention. Let's see, where's my stuff? But yeah, that's there. Let me see if I find. Oh yeah, here we go. Here's the drive, the steering column. So yeah, you really need to know how to and other stuff over here, other iterations of the car, of the drive shaft. This is one design I'm thinking of doing, but yeah, we need to see if we're gonna do that one, or we could just buy parts. You know?
Maybe buying them, you always get a better one. So yeah.
Yeah, but this is pretty much the model.
Yeah.
So you need to know how to build these parts. You know.
Yeah.
Yeah.
So yeah. Maybe I will first start by adding the battery. So I think beneath here is a good place for the battery, right? You think? Look, this one looks quite nice like that.
Yeah, that's good.
So
yeah.
last time I did like that, but it always kept having short circuit for some reason. So maybe it's because of the metal. So here's more like metal free. So I think it will be good. So of course I need my trustworthy friend, the duct tape.
Oh yeah. Of course.
I can never go a day without duct tape. Duct tape is the thing which makes magic happen. So here.
Yeah, Siren. Yeah, the car we drove it to the left. That's why it veered into the wall. But I'm pretty sure we probably lost control because it probably went out of the Wi-Fi.
I don't know. I mean,
it probably did.
It didn't have a brake as well.
It didn't have a brake, so it just.
So even when I stopped, I cut the power, but it still continued.
Yeah. So we just went left, and it crashed, and whatever. No, we had some kind of control. It was just going too fast. We had some kind of control, but
we had only full power.
Only full power, and it's just insane. Right now, we can throttle the power now, so we won't have those problems now. Well, at least we hope not.
Yeah, if you're capable enough, at least.
Yeah. So it should work a lot better now.
Well, so here's the power bank and
Hey, we got a new follow, Mechpunk, or I don't know how to spell your name. Thanks for the follow.
Yeah.
So. The car was furious and too fast. Yeah, it's crazy. Yeah. I see. Well.
Okay.
Okay, sure, Maddie. But yeah, Siren, you asked earlier. You wanted to make sure if you needed to actually know 3D modeling for people to print it. I mean, you can download files from Thingiverse or whatever, or any other 3D model file, and just send them over to get printed. I mean, you don't have to make them yourself, but if you want custom stuff,
I think you also
it's
learned
better.
it quite fast, right? You learned, I think, in 1 or 2 days.
The
3D modeling a little bit.
I wouldn't say 1 or 2 days. I've been at it since September or something like that.
So we also just power on the Raspberry Pi and see if there's some if this works already. The Raspberry Pi
sure,
Plus.
do it, yeah.
So I can also just let's just add a screen just to see that it is indeed a computer. Maybe it's nice to see. So here's the screen. And here's the HDMI cable. Okay, lovely.
No, I mean, you just need to find a model. I mean, you can ask somebody else to, if you want something custom, you could ask somebody else to print it for you, make it for you in 3D. But it's it'll probably cost you money.
Maybe we can also put our files online one day when they're good.
Yeah, we could put our files online one day when we're good, but not right now. I mean, it's all kind of
it's still very
weird hodgepodge of stuff right now. Our design, so I wouldn't even call them design. They're just like the bare minimum we need to have like a running car.
Yeah.
I mean, it's not something that looks good in any way. Yeah, there you can see the Raspberry is turning on.
Yeah. So actually, I don't need it anymore. So okay, let's explain. So this is just a screen attached to Raspberry Pi. I think how you normally would also control a computer. I also have, of course, a lovely mouse and a keyboard. Let's get that one. Here. So I have a mouse.
Yeah, ouch, ouch.
Yeah. Let's put it in the right socket, like there, and the keyboard. So as you can see, now the Raspberry Pi is turning on.
Yep.
Yeah. So, but what I actually am going to do is control the Raspberry Pi using my laptop. So what you can do is use an SSL connection, where I don't know actually how it works, but you can just control with the terminal on your computer the Raspberry Pi directly. So it's really handy because I don't want to type on this little screen and use this keyboard. It's a little bit annoying. So you can just use your regular laptop and control your Raspberry Pi. It's very neat. So that's actually what we're going to do. But yeah, everything seems to be fine. I mean, the Raspberry Pi seems to be powered. So this is of course a minimal requirement. So I think we can also maybe continue. What part should we attach now? Do you want to add the battery or the electronic controller?
I think add the battery.
Yeah, it's the clunkiest part, I think.
Yeah, just add the battery.
Maybe here.
Yeah, exactly there. Right there.
Nice. It looks really good.
Right there. Also, the nice thing, the battery is probably the heaviest part.
Yeah.
So put it over the rear wheels, and it
more traction.
Yeah, more traction. You know, like just like real cars. You know.
Yeah.
This is like a mid-engine car, like a Lamborghini. You know, they're all mid-engine, like engine in the middle of the wheel. So you know.
Although we only have back-wheel drive.
Yeah, we already have rear-wheel drive, but of course most of those cars have it too. I mean, a lot of those modern supercars are introducing four-wheel drive, but really, rear-wheel drive is you know the main thing those cars have always had.
Okay, so cool. Okay, well let's add another one. Okay. So now I'm going to connect to the computer with my laptop. Let's see if it works. If it works, and I do indeed not need my screen anymore. Sometimes I need to check my IP address of my Raspberry Pi to connect, because we are at a how do you call this? A workspace, and apparently your IP address changes every day. Really annoying.
Yeah, it's DHCP to where you connect here, so it's you know, it gives you a new IP every time you connect. If you're hearing anything weird in the background like this, it's because we're printing something for another
maybe
project.
you can also show that while I'm trying to connect with.
Well,
Raspberry
maybe
Pi.
if
Do you want to turn it, or do you think it's maybe people can just see the 3D printer?
Yeah,
it's not. So this is our 3D printer
yeah,
in action.
Yeah, you can see it's busy right now. So the project is kind of secret. You can't really see anything there, but yeah, if you're hearing the sound, it's like that, or actually on screen is that. For me, it's there. Ah, this is better, like that. Yeah. Now it's the same. Now, because it's right in front of me, and the camera's here. Yep. Hello. Yeah. So yeah, it's kind of high pitched sound, and sometimes it even sounds like it's singing. It's like ooh, ooh, ooh. This is really weird. It's like Close Encounters or something.
Oh man, I have to close all my windows on my computer apparently. Okay. Oh, still not. Okay.
Yeah, exactly. Yeah, I was wondering if people were hearing it. We have a directional mic, a shotgun mic, but oh yeah, the whales. Yeah, but it still picks up the. Let me fix that a bit. It still picks up the printer. Yeah, there's the mic.
Okay, so my laptop is also connected with the Raspberry Pi. Yeah, so everything seems to be working. I can also I just disconnect the screen. I mean, we don't need it anyways.
Yeah, sure.
I just wanted to be sure that we have a connection. But, seems to be fine.
Let me see how long. Did you bump the mic?
Oh, maybe. I mean,
the print is over in about 20 minutes. So then it should be okay. Then the sound should be gone by then. Let's see.
Okay. So yeah, okay. The battery is in place. The Raspberry Pi, our other battery. So I think we can. Yeah, what should we connect? Yeah, let's connect maybe the front servo with the Raspberry Pi.
Sure.
So I can also just say how to do it, because there are a lot of ports, as you can see. There are I think 40 pins, and you have to find the correct one to connect with the servo motor. Let's get some nice wires. Which one did I use?
Nice wires, the best.
So I like to use these kind of wires. I think yes, those are the correct ones. So let's see, Twitch. So these wires, you can just. I mean, I don't like to do soldering. I just like to, let's say, hot plug cables. These are really nice. So there's a female end here and a male end over there, and you can just put them in and connect them. It's really nice. Of course, you have to somewhat keep the same color scheme. So as you can see here, it's brown, red, and orange. So I also use cables over here with red, brown, and orange.
So let's put it a bit more here.
So yeah.
And it's a bit more centered.
Okay.
Yeah, there you go. That's better.
So I add I like to also add more cables that I can always change it later on. So like that. So I just extended these cables, and now I can plug them in the Raspberry Pi, and now I have to look at the pinout, how you call it, the scheme of the pins to see which one has to go where. Pins. Maybe I should have taken a picture. Yes. Okay. Cool. I know which one is which. So this is just the normal cables of a servo. Servo motor is actually just a DC motor, but it makes very discrete steps, so you can say exactly where you want to go. So you can say I want to be on 180 degrees or 90-degree angle. So you can fine-tune your angle. With DC motor it just turns, but the DC motor can just have a very fixed location. So which is really nice for steering. Oh yeah, Drew. And there are 3 different colors, as you can see. The brown one is the ground. The orange one is the signal, so which actually says go there or there. And the red one is the plus, so the 5 volts I think. So 5 volts, the ground and the signal. And the signal is, by the way, a PWM, pulse width moderator. But yeah, I don't want to go into too much detail about that one. So let's see.
You can Google it.
Yeah, you can Google it.
PWM, I mean,
yeah,
everywhere.
So the red cable should be on the plus, and there are 2 pluses over here. So this one is a plus, and this one is a plus. So, oh wait, the red one. Let's put it over there, I think. It's nice. So this is the plus. And the ground, you have a ground, you have multiple grounds. But one of the grounds is over here. You could also hear it tweak already a little bit. And then we need the PWM output of the Raspberry Pi, which is port, which is pin number 12, and that's 1. So it's 1. Oh no, wait, it's 2, 4, 6, 8, 10, 12. So that one is number 12, if I'm not mistaken. Like that.
Yep.
Yes. So, well, maybe we can check it out.
Check what out? That if it works?
Yep.
Yeah, try it.
For fun.
So this should turn the wheels, to steer. It's for the steering thing.
I can just open this one.
This de nieuwe met die 100% infill toch?
Yeah, I think so. Yeah. Yeah.
Don't lose it.
Yeah. Why does it give me an error again? Maybe there is something in my code. Let's go to the code.
Yeah, looking at the code right now to get this this servo moving, so we can check if the directional control works.
Yeah.
Can we check out that 3D print? How long still? Yeah.
Ah, yes. Oh, I know why it didn't work. So I wanted to use the code which also uses this board as well, because I want to use the code which I'm going to use at the end. So I have to first attach this one to the board, because my code was whining. I cannot find this board. Oh no, what should I do? And yeah, so let's just attach this board to this one as well before we can try that one. So let's continue our wiring. Let's go to the wire scheme again.
Wait, what's this? You need to attach the head?
Yeah, so I have to attach the head to this one because I want to use the code, which also has this board involved. And it was like, oh, I cannot
Yeah, you want to put it directly.
Yeah.
Yeah, but that's yeah.
So no, yeah. So I want to just use the code, which can also use this one. So I want to do
But whatever. Let's just put the head on it.
So let's just put this one as well. There are multiple pins which you have to use. It's a little bit more complicated than this one. So you also need a ground and a 5 volt. And let's see. I think I used this one.
Yeah, the 3D printer's a crybaby.
So as you can see, these are all males, and these one are also all males. I think you can already see why they are called males and these are called females. So I need a cable. Yeah.
Oh, no.
So I need a cable which is all females. So yeah, so let's add the females on this board. So of this cable, of this board, I need the 5 volts,
He just assumed
ground.
the cable's gender.
Yeah. Let's see, I think I did gray as ground last time, so let's do that. So the gray one is the ground, and then I have to use the SCL. Oh wait, properly. Like that.
Fine, no girls on board then.
So oh wait, I think I can better use this one first, just because. Yes, because these one are more fixed. Okay.
Yeah, he's got a picture of his color scheme.
Yeah,
of the,
I have indeed of
the Raspberry.
video.
Of the Raspberry Pi on
Yeah, so
on his screen.
I can just also put it in a Twitch, right? And people can see where I'm looking at. So I'm looking at this. Oh, I cannot send links. Oh no.
Send it to me. I'll put it on the. Send the link through Slack. I'll send the link on the so people can see what we're looking at.
So this is the screen I'm looking at. And now I have to do the wiring correctly. I think I used this one.
Oh, what's going on? My internet's kind of acting weird. Did you send a good link?
Yeah. As you can see.
It's slow.
Huh? It works for me.
Yeah, that's Moobot. He kicked his ass. Oh, there we go. Actually, I think I'm gonna just.
I'm thinking, should I use the 5 volts or 3.5, 3.3? Oh yeah, I could use both, so that's fine. So that's.
Check out that link. That's where that's what we're looking at right now.
Yeah.
The scheme for the pins at the on the Raspberry Pi.
Yep. I'm also moving the ground because I need to use the ground for the other board, but that's just a minor detail.
So which one do you need?
So I need I need pin number 3, 4, 5, and 6. I think I'm going to use those because it's fine.
Yeah.
Yes. Right? Yes. So last time I used the 3.3 volt instead of the 5, but I think I will just now go for 5.
Yep.
Let's go fancy. Okay, so the ground. Like that. Okay, so now the gray one is ground and the purple one is the 5 volts. Maybe we can already just attach those two. So the gray one is the ground. And the 5 volts over there is the power. So as you can see, it already lit up because it got its power. That's the ground and the power. But now we need the signals, of course. So the signals are the ports 3 and 5. So let's just put it in and then concern later on which is which. Like that, nice firm. So at the moment I have the blue one at number 3.
Yeah, it LED lit up, so it turned it's on.
So the blue is the SDA, which is next to purple. And the green one is the SCL, like that. Okay, now it should be properly attached. So let's now try my code again to see if yes, no problems. And you can already hear the humming. Maybe also let's make a little plateau and use the box for that. I don't know where it is.
What box?
I don't know. I think this will also work. Just to prevent things from spinning. Okay, cool. Is it fine? Looks good, right?
Yeah, it's fine.
Kind of. Yeah. Maybe we can better use 2 things, but...
What?
Or is it fine? Yeah, maybe. And last time I did one here and one there, but maybe it'll work. So as you can see here, the thing. So let's now try to control the steering mechanism. Let's go there. Yes. Oh, and as you can see, it can move. Now it went all the way to the right, and now it goes all the way to the left.
Yeah.
Yeah, it works pretty well. And yeah. So, do you think they want to see the dashboard for it or something?
Sure.
Maybe you can show it. Maybe I could do it on my mobile phone.
Yeah, show it on the phone.
Yeah, show it on the phone.
We have this software, well, machine engine. That's the software we're using. We're developing it ourselves. That's the software we're using to do all this, to control the car. And you can do it on a computer or on your phone. You just need to hook it up to Wi-Fi, and it works.
Let's load it in Google Chrome. Yeah, so this is how it looks. See, you can also see it.
Bit lower. Bit lower.
Even low? Okay, like that. So as you can see, you can also see the steering. Yeah, you can also see the steering mechanism. So if I do like that, I think it's already all the way there. So if I go the other way, you can see it move. See?
Yep.
Then you go the other way, and it goes the other way.
Yep.
Lovely. Woo. So this is how the steering works. So yeah, let's also add the other motor, I guess. So the other motor is attached to the ECL. ESC, that one. And well, the wiring of the motor to the ESC is quite easy. The red to the red, and the black one to the black one. I think that actually doesn't really matter in this case, because the DC motor can spin both ways anyways. So if you would turn the cables around, the electrons would just go the other way around and the motor will just rotate inversely. So in this case it doesn't matter, but in some cases it really does matter. So in theory you always want to follow the color scheme. So yeah, let's add this one also somewhere. Where do you think it would be nice? You want it here?
Sorry.
Yeah, mistake.
Whoops, sorry. That little mistake there.
Okay.
Yeah,
so let's add
I hit the wrong button.
Yeah. So let's add the ECL, ESC. God damn it. Okay. Like that. Lovely. Looks
Yeah.
pretty good.
Real nice.
Yeah. So now the other part is adding these cables. So these work actually quite similar as the servo. So I have to. So in this case, the black one is the ground, the red one is the 5+, and the white one is the signal. And if I'm not mistaken, it should be like this. I think that was it. Not a lot of cables.
That's it?
Yep.
Less cables than I thought.
Yeah, well, I also minimized some cables.
Oh, okay.
So normally, also one thing you should note, normally you also have to add power to this one, because the power used for this...
more duct tape.
Yeah. So the power used here, the 5 volts, is just to power the board, but you need another 5 volts to power the servos normally. So that's why you also have to add another 5 volts over here. But because this motor has its own power source, you do not need to add the power here. Oh, that also makes me think. I should also not do this then. I mean, maybe it doesn't matter in this case, but I think I will just do it to be sure. This is, yes. So let's also just remove the power entirely. Yes, this one, I think. So I also just, as you can see now, I have just 2 cables attached instead of 3, because we do not need the power cable in this case, because it has its own power. Yeah. That. Yes. Huh. It looks way less than last time.
I don't know. It does.
Yeah. I think everything is attached. So, well, let's just try it out. Okay, more duct tape, of course.
Yep. More duct tape.
Okay, let's add this one over there. Lovely. Luckily enough, duct tape doesn't really conduct, or else I would have been screwed big time. Maybe it does conduct a little bit. I don't know actually. Maybe you should not do it like that, but I will. Okay.
I don't know.
Okay, let's do some duct taping for the cables because they're all flopping around. So yeah, this one maybe like that.
Yeah, attaches
nice.
there. Yeah.
I have to get it up. Yes. And let's just.
I don't know what kind of tape.
What?
Just your normal, like plastic tape. That would have been crap. Really bad.
Yeah.
Really bad. Bad times. What?
I know what we should do. We didn't.
You didn't attach the
battery.
It's on this side.
Yeah, I think you're right.
Yeah.
Yes.
I was wondering what's
Yeah,
with
I was
all
like,
the.
there's like a little bit less cables than normal.
Yeah.
But we missed still the cables of the big power supply, of course.
We almost
forgot a very essential.
Well, we forgot it,
Yeah.
but we almost started driving without battery. Without,
yeah.
Like, oh no, what's going on? Crap.
Ah,
No.
nice.
We forgot cables.
So, okay, cool. Okay, see, here there are nice little
Yep,
holes.
so are we.
Quite big holes. So now we need these cables. And I think here's the plus, here's the minus. So the minus is the black one, and the plus is the red one. Yes, I'm still alive, so that's good. Okay, and now we have to attach these two. And as you can see, they're not very compatible. So I made.
Can they see?
I don't know. But okay, maybe I should just pull this cable out before I'm going to do some trickery, because I don't want to be shocked on Twitch. This one's always bitch. Yeah. Okay, so let's attach these nice copper cables. So I just do this in order to make them compatible. So
there's probably an adapter, but
yeah,
whatever.
Maybe there's an adapter, but this
I'm
also,
pretty sure there's an adapter.
This works really well.
But you know, cheap. You gotta keep it cheap.
Yeah. We had copper wires laying around anyways. As probably always. I think a lot of people have them. And then the other one. And the other one. So. Okay. So just to recap, I just did disassemble this one just to be sure. I don't want to short circuit myself or short circuit the battery, because that one will break. I will probably survive, I think, but they're pretty powerful batteries, I don't know. Okay, so now they're nicely safely isolated from each other. So the next step, this is the red one, to add it here, like that, and the other one, like that. Cool. Okay, let's also duct tape them, because they may not go loose and short circuit, or else I think we lose our battery.
Yeah.
Oh, yeah. And the other one. I think this case it does really matter, the plus and the minus, because the ESC I think is a little bit more complicated than the DC motor. Like that. Good. So now we have our nice converters, you can see. Ah, yeah, now it looks already a little bit more like we are used to. So let's plug it in. Okay, now we have only one thing still hanging around, which is the switch of the ESC. So this is to turn it on and off. Yeah, so where should we put the on and off button? Do you think, is it fine here?
Yeah, I guess.
Or do you want to have another space?
Doesn't really matter.
No. Over here, like that. Okay, I think this is it, right?
Yep.
So I think we can just turn on everything. So there's quite a big procedure to do this, because the ESC has a starting sequence, which I actually figured out today, or actually last week I already saw something about it, but today I finally know how the starting sequence works of this ESC. So I have to turn on my program and ESC about the same time. So now I turn on my program and then the ESC, and now the ESC will be programmed by my yes, and it works by my programming sequence. So that works.
Yeah, I don't know if you heard the beep.
Yeah, so
probably you probably did.
Maybe now you can see the light blink over here, which means it's programmed properly, or it's programmed at least. If it's proper, that's of course another question. Okay, so let's see if we can control it.
Yeah, they heard the beep.
Yeah.
Beep beep beep.
Oh no. Let's go like right there.
What are you gonna do?
I'm just going to control, check if everything works. So let's go to Slack again. Slack. And okay.
Yep, just starting up the dashboard to control the car.
Yeah.
It's not gonna go anywhere. We put it on a platform. So
Yeah.
I mean, let me turn that a bit.
Yeah.
Like that.
Nice. Just for the people with OCD or something.
Yeah.
Okay, let's see. If
Well,
our-
this edge
Yeah.
is crooked on the cameras or whatever.
Yeah. Okay, I think everything works. So let's check it out. So as you can see, the steering still works. But now in theory, this one's also attached. So if I do the button go in front and then power it up. Ah yes, like that. See?
You probably
Now it's
hear the
turning.
sound.
Yeah. It's also really wobbly, as you can see. And also the sounds are really nice. I think this sounds resembles a little bit of a motor just starting.
The engine of a car.
Yeah. And if you can also
Okay,
just go
that
harder.
tire is really wobbly.
Yeah.
Way more than this one is not that bad.
I think maybe you also need to attach some points over here, I guess.
I mean,
now it's all in the middle, but maybe at the end, maybe some stabilization is also really nice.
maybe.
So we can also power it up even more. And more. So it's quite powerful.
Yeah.
So I think our first three we did with these motors, they were way less powerful. I think some people might know the difference between this motor and this one.
Yeah.
You can also go back.
I'm gonna check out that wheel because look at it, it's going crazy.
Yeah. But I mean, it works. So it can also go back. So now it's going backwards, and I also can go faster backwards.
Boom, 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 boom.
So yeah. And also I made a stop button. So if you go front, you can stop. Oh wait, pause back. And if you go front, you can stop.
Yep.
I mean, the programming is still not perfectly. I did it all today, but it seems to work pretty nice. So shall we maybe go for a ride?
Yeah. Okay, try spin it. Spin it.
Oh no, it will be like that.
I have an idea to fix these wheels messing up. but no, I don't have.
I think we have to add some things here.
Yeah, but you can add a screw, you know.
Maybe
Add a bolt.
I think it's not good to add more than 2, so maybe we really have to put this one here and this one over there. If you have 4, then alignment is very critical. Maybe if the alignment is not that good of the layers. I mean, we have to put this one over here and this one over there, I think.
Yeah,
and not to add another 2. I think adding another.
No, I'm just talking about a loose bolt.
The bolt.
Just a bolt there, so that we can get it straight. And you screw it. You screw it on.
It's also really wobbly, anyways.
No, but I mean, to get the wheel straight, you can just use the bolt for it. I'm gonna try that.
Yeah, later on. You mean, or now?
Later.
Okay. So shall we just take it for a spin?
This setup isn't mobile yet.
Well.
Just put it on the ground for now. The printer, we gotta wait for the 3D print to finish.
Hey, you also used your mobile phone last time, right?
Yeah, but I don't have that attached anymore.
Ah.
Bring that forward. Sorry.
So let's try it out. This is low speed, by the way. This is all. I think it's slowest. And then you have a brake, and then you can go backwards, faster backwards. And this is on the slowest, of course. And then brake. See, the brake also really works. What if you go a little bit faster and brake? And the braking is nice. It's still not the fastest because I don't want to crash it, but that was really nice, right?
Yeah.
So I think we let's go over there. We have way more space.
Yeah. Drive. They probably can't hear you because you don't have a mic. If anybody's saying anything, I can't see you right now because I'm away from the computer. Oh. Just setting up the camera. Broke what? It's stuck on the cable. Get it off the cable. Lift it up. Yeah. Okay. So we're gonna move the setup in a bit. We're gonna go to the because we have a bam. We have a second little RC car. This is just store bought. We just bought it at a store, and we're gonna see. We're gonna have a little race or something, and see what's what. Yeah, hold on. The 3D printer is still doing something, and then when it's done, we can go. Yeah, it's gonna pull it out. So.
Okay. In the meantime, it's still just rotating.
Yes, yeah, man.
Do you see the thing rotating in the back? Let's see. So sometimes you just see him coming by.
What do you mean? Oh, there. So he's like running circles. Oh yeah.
I hope there will be no car coming in.
Yeah, exactly. Yeah, nice. So let me see some chats over here. Yeah, it is pretty smooth. We fixed a lot of the problems that it had previously because because of the ESC you can solve because of the ESC, a lot of the problems we had before got solved with the smoothness and all that stuff. And also, it's a better build because it's less wobbly. It makes less friction. So yeah, it's a much better build. Yeah.
Do you think you cannot just assemble it already, like, or
Assemble?
The 3D printer.
Well, if I pull it out, it's not gonna send the commands. So it's just a few minutes.
Okay.
No big deal. But anyway, so
Yeah, I mean, we can also just talk about big improvements indeed over the few weeks.
you can pull back. Yeah. So I mean, put the big screen. Yeah. So yeah, I mean, a couple. Let me get in front of this light. It's kind of messing with the camera. Oh.
Yeah.
Get out of the way. Yeah. Yeah, the light. Yeah, the big improvements were in the build itself. I mean, the previous parts that we designed were like really like wobbly and stuff like that. It depended too much on like exact screwing things exactly the perfect way. But now we made sure that the parts themselves connected only in one way and only at a certain distance from each other, which reduced the friction and the wobbliness of the whole thing. So now it's all like smooth. Yeah, that's the big difference with the 3D
yeah,
printer.
and also like, oh yeah, it's finished almost. Nice.
Yeah, also like.
So we also extended this arm. So as you can see here, there's an arm from the steering mechanism. So here. And we also made this a little bit longer. The previous was a little bit smaller, and we could not make a very good turn. So
Yeah.
Like,
Yeah.
I don't know, 15 or 30 degrees. Or so. Now I think maybe 10 degrees. Now I think now it can do a proper 45 degrees.
Yeah. Also, one of the big changes was that we extended the length of the steering mechanism.
So it was the wheel was
the wheel was the wheel was hitting the chassis. So we solved that by making the wheelbase wider, so the wheel could turn more. And we also designed a mechanical stop, so that the wheel doesn't so it has like a physical limit, so that it doesn't just turn and then like the wheel hits the chassis again or whatever. There's also a software stop. We got two stops, so if the software fails, we still got the physical stop. Yeah, so it looks like the printer just finished. Let me check if anybody says something. Yeah. Yeah, turning was always a problem, but now it's a lot less of an issue.
It will still be an issue, I think. That will be just programming.
Yeah.
Programming can just fix that. But as you can see, it can at least make a nice round.
Yeah, exactly. So yeah, it's gonna move it. Yeah, we're gonna be moving these the setup, because we're gonna go to the track over there, and we're gonna be driving the car.
Also, the car is connected with the power of the Wi-Fi, so we will have a limited range.
We don't know exactly what the range is, but it's gonna be limited. Yeah. So I'm just gonna put us on break, and we're gonna come back in just a bit after we set it up. So see you guys in just a few minutes. Don't go anywhere. Yep. See you. Hello, hello. Okay, so we're back. We set up. We moved to the new place,
Can you also look at the camera?
and
Or the stream?
just checking out if anybody said something. Yeah. So this is what it looks like now. We're
I want to go see. No, it's more like I want to go where the camera is.
sorry. Can I just move the camera a bit?
So we're also going to
Ah, hold on. The mic fell.
Everybody's deaf right now.
Yeah. Sorry, the mic fell. Still moving some things around. Hold on. Yeah. Okay.
So we're also going to compare our creation with a normal RC car we bought in the toy store. How expensive was it? Like 15 euros or something?
Yeah, it was 15 euros. It was pretty
like really
cheap.
cheap. So, and
So-
we've actually not tested our car to the fullest potential. It will be scary, man.
So I'm driving the store-bought car.
Maybe we should first check where the Wi-Fi ends, or else
Yeah.
maybe it's like.
Not
shit.
gonna race now. Just putting the car at the
Maybe it would
spot.
be better to start over there because for sure we have Wi-Fi over here, but not there,
Wait.
or else we cannot brake.
So yeah. Okay. Sure. I'm gonna drive.
Okay, I'm going to check where the Wi-Fi.
I'm gonna see how far I get. So go to the. Whoop. Yeah. So we have a lot of space here to work with. So. Okay, so that's the limit. Okay, that's pretty good because we can race from from there to there. Oh, he lost his connection. So yeah, we know now. We know where the let me stand in front of this light. So now we know where the thing ends. The Wi-Fi connection. Yeah. So now oh shit, that's mine. Sorry, I hit the button accidentally. Gotta start at this line. Is this too far? Yeah. So we lost connection, but no matter. It's fine. Stupid lights. A lot of lights over here. So we're gonna fix that. That's where he's standing. That's the limit of the Wi-Fi right now. So also you lost the stream. Oh, I just saw your message. Is the stream okay now? What are you doing? You're not standing here? Wait, some people are saying it's good now. Okay, nice. Yeah, so I'm driving the store. I mean, you can barely see the cars, man.
Yeah, you can see them. Kind of like 2 pixels
Yeah,
each.
hold on, let me. We're getting fast.
What? What's the problem?
You can't see us.
Oh, do you want to use another?
Just gonna
Oh,
light.
nice. Whoa, I I'm blinded.
Yeah.
I think it's fine. As long as it's not turning in my face. But is it really necessary?
Yeah, because they can't see us.
I think they can also not see the cars.
Oh, the cars are fine. The cars, you can see them coming in from this.
Yeah. I mean, it doesn't really matter, right?
What is it?
Maybe you can also, I don't know. He's assembling a light to whatever it is. Very big. I don't know, maybe you can also, did you already like show today the little hall we are in? So maybe you can also just turn it around just to see. So this is the hall we're in. It's a really big hall. So we are actually located in a harbor of Rotterdam. As you can see, there are like a lot of startups and also big companies over here. It's really nice. I mean, we have a lot of space over here and it's pretty cheap to rent. Relatively cheap. So that's nice. So let's see if the chat says something. What do you use for chat? This one? So is it working?
Yeah, I just dropped it.
So still assembling the light.
Yeah, because we're like in the dark.
Yeah.
We've got a backlight. Gonna fix that in a bit. Sorry about the delays, but whatever.
Okay. How does it work? This one. Okay, cool.
There we go.
Okay, everything fine.
Okay.
I will not go full throttle the first time because I don't trust myself.
Yeah. Yeah, we shouldn't go full throttle yet.
Not yet. Okay.
Hold on, stand over.
And I'm blind.
Anybody say anything?
Not a lot. Only there's light and stuff. I guess.
yeah.
Okay, let's try it.
Yeah, let's try it. Go straight, just a
Wait. Okay.
just a straight line.
Okay.
Oh, that's pretty straight.
Man, I don't go full throttle or something. Man, was it a straight line what you did? Was it really a 10 for straight line? Man, I was trying.
That's I had some spatial anomalies. Yeah. There was actually a straight line from the perspective of the car.
Really? Dang.
No, I don't. It had some steering problem, but then I had like massive understeer.
Okay, let's go back. Well, at least I won this time. Woohoo!
Really?
Yeah.
I actually covered the most distance.
Yeah, that's right.
Oh, I mounted something. Hold on, let me grab it.
Okay, I'm trying to go to the.
Okay, so yeah, that was that was a very straight line in a curved space, you know, relativity and all that. So yeah, pretty cool. let me get the car back in its spot. Okay. There we go. So let's reset this thing, and yeah, let's see how far we get. Yeah, he says he really loses connection over there, so that is the limit of the Wi-Fi connection over here.
The yellow, but let's just.
Yeah. So we go again?
Yeah.
I guess go.
go more for full throttle. Woo! Oh, do you see the slip? It slipped really nice.
Yeah, my car goes max 15 kilometers an hour. I think ours can do what? 50?
I have no idea. Okay, let's put it back on again, or?
Yeah, let's go again. Let's go again. Okay. So we're just trying to have a race, but we both suck at driving cars. Yeah, exactly, Sarah. It's a straight line, man. You know, curved space.
Okay.
We could try some donuts and stuff like that in a bit.
My brake's really good. I will brake this time before the yellow line.
Okay,
really
nice. Okay, okay. Let's go. Go, I guess. Wow, yours, man.
But I did brake. Or
Yeah,
at least I tried to brake.
You broke it. Yeah, yeah, it broke. Woo! Drifting.
I'm really happy that we made a bumper.
Yeah, we made it. The bumper worked.
Yeah, well,
Yep.
again.
It's stuck on the wheel. Yeah.
We always have to test the bumper. Continuously testing the bumper.
Yep. Boom, bitch.
Fuck you, man. Is there something loose?
Yep. Something moved up. Talk about road rage over here. Woo! Oh shit, I bumped the car too hard. Well, actually, he bumped into me, so, you know, you saw it, you all saw it. Yeah, it's a test drive. What'd you say? Yeah, we have to restart the car. It's it bumped the Raspberry Pi and
Next time you can. Oh man, okay. I first want to drift, and after the drift we can change cars.
I mean, okay, sure. Woo! Spin it.
So let's put it on.
Trying to drift over here. Get a drift. Woo! There you go. Yep, man. He bumped into me.
Yeah. So apparently the cable went off, so the Raspberry Pi turned off.
Okay. Boom. Ooh, sorry, headphone guys.
Yeah, I'm trying to wait until the Raspberry Pi is turned on.
Nice, yeah. Too many lights over here, man. There you go. Yeah, so yeah, it's pretty cool. It's working well.
Yeah.
Working better than last time.
Let me see if everything is going okay. Circuit? I don't know. Let's see. Let's first turn off. Woo! This one.
Woo! Yeah. too many lights. Yeah, so
Oh, I think also the battery is draining quite a bit.
really? Is it?
I mean, it's 2 lamps.
Yeah, sure. Wasn't it charged?
It was fully charged. Maybe it's also not having enough power anymore.
Really?
I don't know.
That's weird.
So, wait a minute. I think in theory I could also power the Raspberry Pi with the big battery in the future. It would be nice. Ah, it has also problems.
Yeah, the human is sitting back here, so you can't see it.
Yeah. Just waiting for Raspberry Pi to boot.
Yeah, Raspberries, they boot pretty slow, so...
Well, normally they boot quite fast, but there's something wrong with this one, so I think I should... Ah, now I know the problem! Oh shit.
Oh.
I need some more duct tape. So
More duct tape.
The Raspberry Pi is short-circuiting the whole time.
Okay, really?
Yeah.
You have to, okay.
So maybe we can also just show it in front. So what happened is that the Raspberry Pi got loose, and I think maybe because of the crash or something, or when the car bumped into this one. So the Raspberry Pi landed on this screw over here.
Sure, that's it?
So when I just moved a little bit, it was short-circuited again.
yeah, okay.
So I think the Raspberry Pi just got short-circuit and just turned off.
Okay.
This is what I think.
Okay, yeah.
So
We'll check that out.
Raspberry Pi.
Yeah, we'll check that out, and we'll see about some more car races in a bit.
Stay tuned.
Yep. Yeah, that's what we're doing now. We're covering the stuff up with duct tape. I mean that's actually something duct tape is pretty good at. You can just like cover it, isolate it, whatever. You're done.
Okay. Let's see if it's on. It takes about 2 minutes, 3. If it's not working, then maybe the IP address is changed again or something. Then get my HDMI cable. But let's hope it's not.
Do a harder brother.
Okay.
So it'll take a bit to power up. So, but yeah, I'll entertain you with some car driving.
Aha, it's on.
Yeah, so the Raspberry just turned on. See, look at this bent space from our perspective. And drift. Woo! Ow! Okay, it got stuck. We can grab it. So, if for anybody who just tuned in, we just finished building a do-it-yourself RC car. And we have a store-bought RC car.
And this one.
And this one.
This is our own made
Yeah.
RC car.
Yeah, we built this one ourselves out of like 3D printed parts and some metal parts and stuff like that.
Big expensive RC.
Yeah, and some Raspberry Pis and stuff like that, and then now we're just testing it out. We have this store-bought RC car for like 15 euros. We bought it. We're just messing around with it, and we're testing it out compared to this one that we just built. So yeah, that's why we're like in this huge open space right now. Woo!
So it should be all fine.
Yeah. Okay. So let's see. I mean, up to now, it's clear that our RC car has extreme acceleration compared to the other. I mean, it's crazy. It's just wow. It's amazing.
I will put my laptop here.
Yeah.
I only want to make a drift, and then we can change.
Change what?
Then you can go with this one.
Oh, really? Okay, yeah. The software we use for our own car is Machine Engine. It's a software we developed ourselves. We're developing ourselves. We're planning on releasing it next year. For an alpha is coming soon, but stay tuned for that. So we'll post about it as soon as we're ready for that for the alpha. And we'll be, needing people to alpha test it. But right now, this RC car is running the Machine Engine software, so it allows us to easily connect the car via Wi-Fi to our phone or laptop to control it. But it's not just RC cars. I mean, this RC car is just a test, an initial test. For what we can do with this. You can pretty much connect anything to this software.
Yeah, it's the same thing. What always is the
problem. Oh, you have to remove. Yeah, okay, yeah. Yeah, this Raspberry Pi we're using is not exactly healthy, so it has some weird hiccups. You have to unplug some cables and stuff like that to after it turns off. So whatever, but it's fine.
Yeah, now it works.
Yep.
Yeah, so let's put it over here on my laptop.
Yeah. So it's turned on now, and we're ready for another run. Yeah, exactly, Sirens. This one is always always in trouble. So yeah. Let's see. Oh. Okay, Rick is just doing the final test on the, yeah, and so it should be working in just a moment, and then we'll just continue driving around. Gotta watch out not to bump it. The next next thing I need to build for the car is an enclosure. Well, actually, we'll just buy one. We just buy an enclosure for the Raspberry Pi, because right now we just made a platform. Yeah, right now we just made a platform for it, but actually we should just enclose the whole thing. So we're just gonna buy an enclosure for it. There it goes. Yep.
So okay, I want to make one spin. Then we can change. Should I be able? Yes. Okay. Woo! It is not full speed already, but okay, come on.
Whoa, 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 whoa. Bring it closer, so they can see it.
Yeah, I want to.
No. Drive it closer to the camera. Yep. So it's driving really smooth right now. It's amazing. I'm actually pretty surprised at how smooth it's driving. Actually, I'm gonna change this this setup because the lights are annoying. Yeah. Okay. I guess this is better. No lights in your face, and our light is lighting as well. Okay. Cool. So what you say? The front wheel is wobbly.
Yeah, if you.
Oh, that one. Yeah. Yeah. Boom! Oh, oh wow! Yours is way heavier. Man, it just it just pushed mine away.
You want to try?
Yeah, hold on. Let me bring this
It's
one
really
home.
much harder, so you should really. It's really getting used to it. I would also recommend to just be walk behind it in first time.
Really? Here.
Yeah, sometimes you also have to just so you.
Can I just do that, or?
Yeah. And you have to keep on clicking to go left or right. But you can only steer when.
Hey! Oh shit!
Just that's also right. No problem. So you just push it, and then now you can use this one. And don't go too fast. Yeah, you can also that's steering. So now he's trying it for the first time, but it's really hard. I mean, we don't want to crash it. So yeah, you keep on clicking to the left. Oh yeah, you can also do that. This steers way easier.
Okay, this is hard.
Hard, right? So we have to probably work on the controls. It's really hard. I mean, it takes a long time to get used to it. This is way easier to learn. The learning curve is way lower.
Yeah, one of the goals we should have is
making it easier.
Starting camera. I mean, okay. One of the goals we should have is to have the to connect actually one of these RC drive units with our software, but it's not doing anything. What's going on?
Oh, you have to go this one.
Woo! There you go.
So this one is speed. So this is just where you want to go first.
Oh, like that.
Yeah. So
then
it barely goes, and then you have to adjust speed. And this is the brake. So you can always brake.
What's that?
That's probably part of the RC drive.
It's a rock.
So yeah.
Yeah, we thought there was a part fell off, but it was just a rock.
Which is not uncommon. So yeah, then you can adjust speed. You can always brake, let you know. The brake is really handy, right? Then it feels way less bad.
Oh! Yep.
I think that's now though. Oh yeah, it's still working, great. I think you need to recap the bumper.
Oh yeah, the bumper's
Oh man, that noise.
Yep. Let me check out the car. Yeah, it's looking good. Okay, yeah, it's pretty cool. So yeah, we're reverse now. Whoop. Stop. Whoa, it brought it all the way over here next to us. Forward. Just go to straight line.
I'm so happy that I made a break. It really gives a lot of confidence, I think.
Yeah, it works well. The brake works really well.
Yeah.
But I'm trying to. Why does it keep going that way?
Yeah, so steering is really slow. So you have to keep on pressing. And now you can.
Yeah, I'll do that way. Oh, wait. Let me go that way. Something like that.
Does it work? Should I check it out?
Yeah, the car stopped. Oh shit. Okay, it's coming back. Ah!
Too much back.
Is it driving?
Now it's not.
Oh, we lost the wheel. Let's see. What? Turn it off? Oh yeah, okay.
So as you can see, this one broke.
We have another one.
Yeah, we have another one. So let's have a picture. Can you turn it off? So I mean, oh yeah, this one.
Yeah, I know. It doesn't. It's not doing anything. Oh, there it goes.
Oh, there you
Yeah.
go.
Oh yeah. So he's gonna go replace that part that broke. Yeah, sure. Whoa, the light's blowing me out over here. But let me see. Let me check out the chat. It's possible to move the controls of your RC car to sit like the controller in the store. Yeah, we're gonna look into installing machine engine on one of those kinds of RC car controls. It's a lot more intuitive. It's a lot easier to get used to it, because our current control is way too clunky and whatever. But it's just because we're just using like a web app to control it. So that's why it's kind of. What'd you say? Yeah, I mean, we already showed it earlier, but well, I gotta unlock your phone. But yeah, it's because we're using this web app to control the car, so there's a slight delay. Yeah, let's see. Now you're looking like yeah. Maybe print an easy-to-hold phone case. Yeah, that's possible. You can get a because you're kind of holding the phone in a awkward way. It's probably easier to if you can have some kind of grip on the phone as well. So that would probably be better. Or an on-screen. Well, the current control scheme does work like an on-screen joystick. We have a green bar to speed up and down, and we have some. It pretty much works like a thumb pad, like a touchpad on a computer or a laptop, and your like normal games. And arrows, yeah, we have arrows. Yeah, you told us that we would come off, but we have new parts, so it's fine. Yeah, and it is the wobbly one that came off. If you want to controlling the car in the future as a chat, that is something we thought about. We will be implementing something like that in the future. Yeah, definitely, we're gonna be doing that. Well, not soon, not a chat race soon, but we will be doing that. Yeah, that is one of the things we want to try, to let the chat just control the cars, just like what do you call it? Just like like Twitch plays Pokemon or whatever. It's gonna be completely insane, but whatever. We're just gonna put it on and whatever. Hold on, I'm gonna go talk to Rick for. I'll be right back. Yeah, here we are again. Hi guys. Yeah, we fixed the car. We're gonna try another run.
It's quite loose. Why is it that loose? Ah. Okay, let's do some more screwing.
What happened?
Think you can see already problem?
No. What?
Oh, this is really loose.
Ja, maar die moet je recht zetten.
Wat?
Die kan je niet zomaar. Die moet je recht gaan zetten als je het. Yeah, we had a little problem here. Let me turn the camera so you can see.
We're now screwing stuff. So we also want to make an iteration every week. So every week should be better than the last week.
Yeah.
So we want to learn from our mistakes. And a lot of learning has been done over the couple of weeks.
Yeah. Something. Yeah. The rear. The problem is right now the rear drive unit got loose, so we're screwing that back on, tightening it back up, and then we're good to go. Yeah, exactly. Siren says she can finally look down on you.
Ah.
Oh, it turned back on?
Yeah, I'm going against the cables.
Okay.
Holy shit. Okay, more fun.
Yeah, so right now we're just doing the final checks on this car.
Yeah.
Checking it out, looking at all the stuff. Is this a bit loose?
Oh yeah, it's very loose.
Well, actually not.
It's still.
It's stuck, but it's not in its correct position.
Yeah,
Yeah.
that's a more appropriate way to say it.
Yeah.
So now the other way.
Yeah, everything's looking good. We're
Shit.
What happened?
Oh, I accidentally turned on the motor. So
Okay.
it started driving. I think this is the best. Steering goes well.
Yep.
Okay.
It's stuck, right?
Yeah, it's stuck. Okay, good. So do you want to try it again? So maybe you also can see this is the controller we're using. So we made it ourselves with Machine Engine, but it's the alpha, pre-release alpha.
Yeah.
So here,
Hold
you want
on.
to try it again?
Let me put the camera back. Yeah, there we go. Oh,
Oh, yeah. So,
go forward. There we go. Yay.
then what my add keyboard?
You need to actually hit a button to make it go straight. You know what I mean?
Maybe.
With the current
yeah,
control
to-
scheme,
Yeah.
if you have because you can't really go straight.
Now you're outside of the zone, so be careful. Also, this car really has its own life. So, okay, wait. I want to go straight. There you go. Okay. So now I'm letting it go. Ah, it's pretty straight.
Yeah, it can go straight, but you gotta I mean, with the current control scheme of the RC car, just like with the whoa, did you see that? Went way too fast.
Yeah.
Just like with
And
the
it's on full speed, right? And even can also go faster than we did today. We still didn't go maximum speed on this one.
yeah. The
It
stop
didn't sound that well.
that didn't sound good, but the stop didn't work as fast on that run. What's the damage? What? What do you mean?
Steering is broken.
What do you mean broke? How?
Just go all the way to the left.
Okay, some troubleshooting. Go all the way to the left. Yeah.
Okay, try to go back.
Back? What do you mean back?
That one. Go back to you.
Oh yeah, just forward. Oh, watch out.
In theory it still works, but it is pretty messed up.
What do you mean?
I guess so, let's see for yourself. Whoa, stop! Woo.
I'm like, I'm hitting that button, and it's like, oh my god, it's going, it's going. Can I reverse out of this? Oh yeah, I can. Hey, look at that.
So I remember you always race towards that. So I think it's our motto or something. Yeah, you're doing pretty well.
So what broke? Put it in front of the camera.
Well, so now this is the current state.
Whatever.
As you can see, this is flapping around, which it should not do.
Oh, it broke in half.
Yeah, it's a broken half.
Yeah, look at that. Wow, that's crazy.
We can duct tape. It's not that bad actually.
No,
Just
this
a
you
little
can
bit
duct tape that.
and still fine. So let's just continue. Till
Put duct tape on it.
Yeah. Let's continue till it is not able to move anymore.
Yeah, it's some crazy stuff, man. Yeah, so yeah, that's what you get for 3D printed stuff. But I'm pretty sure if we have it like 100% infill, it's gonna be okay. Right now, all the parts that are breaking have like 20% infill and stuff like that. Oh yeah, here. But it didn't stop working this time. It just just one part kind of broke, but it's not really a part that's it broke. It didn't break in a way that prevents it from working, so that's good. Oh, let me bring back the store-bought car. Wow, nice. Yeah, baby. But yeah, I mean that kind of control that you just saw there, it's impossible with our thing right now because the.
Maybe if we make it better.
No, I mean because of the controls.
Yeah, but maybe we can. And we also missing
A screw?
No, the other thing.
A nut.
Nut.
Yeah. Well, it did it. It's not a big deal to crash. I mean, whatever. It just.
This is already. I think we already broke it 2 times already. 2 streams before, right?
Yeah. I mean, but the funny part is, the first time we drove it, we broke it and we couldn't recover. Yeah. But now we broke it and it's like, oh, whatever. We can
some patches.
Just some patches and we can continue. So it's fine. The car is getting better. That's what I'm saying. You know, the car, the quality is getting higher. Hold on, let me do something. So yeah, I mean it's a lot better than like a couple of streams ago where it would just break and that's it and we had to stop.
Oh yeah, maybe you can also tell what we want to do with the cars in the end, what our goal is.
Yeah, but the general idea of these because we're not just making an RC car. I mean it would be pretty stupid if you're making an RC car with this stuff because you can just buy it.
I mean, if it's a hobby, it's fine.
Yeah, as a hobby, it's fine, but you know, but even as a hobby, you can just buy RC car parts and whatever, and just build one in an afternoon, and you can like drive around and with better controls and stuff like that. What we're actually doing, we're just doing R&D for a robot game that we're developing, and we have different classes in the game. And this is actually R&D for the one of the first classes we're thinking of. Whoa! Look at him go! Boom! Ay ay ay! That was a big crash. Yeah, that was a big. The battery came off. Woo! But it doesn't seem to be broken. It just seems like the battery came off. But anyways, the RC car is a test bed for our future. The business model is it's not making RC cars. Yeah, but the RC car is a test bed for our future robot project. We're testing all kinds of stuff like 3D printing and software and also physical builds and that kind of stuff. So what's up? Yeah, so the goal is to make several robots and have them compete with each other in a game. We're gonna be building a MOBA, but with robots in the real world, and you have to control it via your camera, via your phone.
Wi-Fi.
You lost? Oh yeah,
Yeah,
you
so
lost
I was
connection.
Like, break, and
Oh, it broke.
It broke.
Okay. Now we can't recover.
Maybe.
No, man. No, this is unrecoverable right now. But yeah, so you can't steer.
Yeah, I mean steering is optional.
No, but the other wheel doesn't stay.
Yeah.
You can't drive forward.
I mean, I do agree. It's pretty bad.
Yeah, the steering column broke, and exactly on the area on the part where there's no bumper. You know, I mean, where the bumper is weak. You know, the bumper's not exactly perfect, but we'll fix that. We have ideas on how to fix that, but whatever. Doesn't really matter. Doesn't really matter. Go, yeah, show them in the camera. But basically, we're just doing R&D for a robot game.
So this broke. So we have to probably do 100 fill every part.
Yeah.
I mean, so we also reprinting everything which is breaking, and now we have like a 20% filling. But if you do 100% filling, it didn't break so far.
Yeah, that's true. We need to do for the printing, 3D printing. We need to do 100% infill. That way, they're much stronger. Also, it broke where there's no real bumper, so it's actually fine. I mean, yeah, whatever. We'll keep improving this car, and until we're ready to rumble, yeah. Because this is just R&D, and we're just live streaming our R&D process. I mean, it's not the we're not in the business of making RC cars. I mean, that would be stupid, you know. With what we're doing right now, I mean, that's not what we're doing.
It's pretty messed up. Also, the wheel is very wonky.
Yeah, it's fine. We gotta stop. I guess that's the stream.
Yeah. Maybe you can recap or talk about what we are going to improve. I think we learned a lot, so I think we can talk about what we are going to improve. Let's grab this one. Oh, I thought you would aim it at us.
Yeah, but there's too many lights.
Maybe if you move it down, or we can.
Let's stand over here. Also, hold on. I gotta move the camera. Hold on.
I do love the little duct tape patch over here. It looks kind of cute. Like you have like a little child who has, let's say, bruises and you want to fix it. It looks nice. However, I think this really needs some doctor intervention. I mean, we can patch it and just run. It really needs replacement.
Yeah, exactly. So yeah, that's it.
Regarding the price.
Hold on, sorry. Just some final adjustments. Yeah, so I guess that's it for the stream for today. Some final thoughts.
So what did break, or what did go wrong? So of course, as you can see, well, this wheel is wonky, a little. I don't know if you can see it, but this wheel is bent. So the plastic is probably bent inside. So that's
What do you mean?
See, I mean it's really bent.
Oh, it doesn't
Bent
spin.
inside, yeah.
Yeah,
It's bent
yeah,
inside.
yeah. It's it's on the inside, but that part needs to be replaced anyway.
Yeah.
So whatever.
So this is broken, as you can see. It's like it looks like a broken. How do you call it in English? A keybone. In Dutch is keybone. But I don't know how it's called in Dutch.
Collarbone.
Collarbone. I assume it seems like a collarbone.
From the looks of it, this part is 100% infill.
Really?
Yeah, it's just a thin part,
Oh,
so
yeah,
I'm gonna have to
you're
redesign.
right, you're
Sorry,
so
can I
right.
go that way?
Yeah.
I'm gonna have to redesign that part.
Or I mean, I think the bumper was the main problem. So
Yeah,
I
the
think-
bumper was actually the
so,
main problem.
As you can see, the bumper
Sorry.
just goes. Oh, the bumper goes like that, but not here. So if we had a bumper over here, I think this part would be fine. I mean, I think we crashed also more on this side than on that side. I think. I mean,
Yeah.
for sure in the beginning we bumped to dust this
Yeah,
side a few times.
I'm pretty sure
Yeah.
if we fix the bumper, we
Yeah.
won't have this problem anymore.
Yeah, so as you also can see, there are like 3 issues here. So the wheel is now inside is bent. The tailbone,
Collar.
the collarbone is broken, and as you can see here, something is broken inside. This was patchable. Yeah, so that's the problem because of the bumper. What else? So okay, the Raspberry Pi turned off because of the short circuiting, because of one of the screws,
Yep,
but
yep.
we duct taped it, and now
Yep.
there's no short circuit possibilities. You know, this side's pretty wonky.
Yeah, but it works pretty well up to now. So I'm not gonna spend much time upgrading it just yet. You're just gonna wait for. He's gonna be upgrading other parts before we get to that part.
Yeah.
That's the part with the least problems. This is how does it spin actually? No, whatever. I'm gonna have to figure something out for that part too. But the rear unit, I'm okay with it.
For now?
It's for now. It's the part with the least concern.
Only this part broke, but it was not 100% filling. Now it is 100%.
Yeah.
I think we also always need to have 2 spare ones of these every day,
Yeah, yeah.
just in case. I think we will break them a couple
Yeah,
of times more.
yeah.
What else? I think that is the main thing. I mean, except that, everything went right. The controls could be better. So I think I maybe could also just program the controls a bit more user-friendly. That steering, like you said, you have like a default for going straight.
Yeah. So if you go around the corner, and the car, and then you can just go back to putting the wheels straight, because normally in a I just had the lights, they were blowing us out. Because normally in an RC car, when you let go of the controls, it turns back to its neutral position.
Yeah, that we also could do, yeah.
Yeah, but we don't have that. So I was thinking just have a button to turn you to your neutral position actively. Or but because right now what you need to do is just press the button several times to.
It's very user-unfriendly. I think
Yeah,
that's
yeah,
why we looked very noobish, because we didn't dare to go too fast, or we have to brake.
Yeah.
Yeah.
Also, not daring to go too fast is also because of the car is not that strong yet. But from what we tested now, the bumper works really well. I'm actually surprised. This side survived several crashes.
This one has
This side has
3 issues. 1, 2, 3.
and they all happened at separate parts, not at the same time either.
Maybe this one.
No, this
same
one,
time.
maybe
those
that
2.
one, but this one was a
separate,
separate issue. So it's pretty interesting that the bumper actually works well. We just need to fix it for the next time. Also, gonna have to redesign this. The holder,
integrated, you mean.
the holder for
so
the.
now it's like 2 different parts.
I'll hold it higher. They can see it.
So now it's like 2 different parts.
Where are you talking about?
Here. So now one part is like, it's not integrated, so it's like duct taped next to it.
Yeah,
it's
yeah,
quite wonky,
yeah.
it kind of
Yeah,
works, but
yeah. So the next iteration, we're gonna be redesigning this area, the front controls, and the bumper, and the control servo.
Yeah.
So we're gonna be redesigning that.
And then the software side, just make it more user friendly that you can always go straight.
Yeah,
Sounds
exactly.
good.
Yeah. I mean, how would you do that actually? Because would you do it at like press the button, it turns, and then we let it go, you go straight, or will you do, or are you gonna
Maybe
implement just
slider that you can slide.
Okay.
Maybe in 3D space.
also an extra button to do straight, just automatically,
or
would also be useful. That the slider works, so you lose the you let it go, it goes straight again, but just in case, just like the stop button and then a straight button,
Is it as necessary? I mean, if you just remove your finger, you're going straight anyway.
Yeah, I know, but that sometimes fails. I mean, things fail sometimes. Because sometimes I stop with the stop button because it didn't work. Sometimes I hit back and then I stopped.
Yeah, but
So it's like it's nice to have two options at least,
yeah, we can see.
Yeah. But if you leave the scheme the way it is now, an extra button to make it go straight is good, or you turn it to a slider.
Yeah.
That can work.
Yeah. So I mean, I think the slider for the power is pretty nice, right?
Yeah. The slider for the power works well. It gives you a good indication of how fast you're going. Let's see if there's any questions on the chat. Let's see. That's pretty broke. Yep. Yeah, of course they aim at the weakest point,
Yeah. It again took an arrow in the knee.
Yeah. Chicks dig cars. Well, I guess maybe. I wouldn't know. I'm not a car person, so. Yeah. Yeah. So I think that's it for now.
Yeah.
I mean,
the other competitor. Our car went faster than this
it's
one.
way faster. Man,
Yeah, we didn't even go full power.
No, man. No way. We didn't. This thing goes max 50 kilometers per hour. This thing is like at least double, probably triple.
Yeah.
I'm thinking we can hit 50 kilometers an hour on our car.
But then we have to also incorporate that if it loses connection with the internet, that it stops automatically.
Yeah.
That we will need when we.
Yeah, I think on the software side, that's like the next thing you need to do.
Yeah.
One of the next things.
Yeah, but maybe it's a lot of programming work. So maybe I do it in the next version of Machine Engine that I will have an automatic function for it.
Okay, like that. Yeah, sure, you can do that. But yeah, definitely some work for next week. Yeah. Okay, let me see. Anybody asking anything in chat? Yeah, not a chick, exactly. But okay, yeah, I think that's it for us for now.
Pretty good run for today.
Yeah, pretty good one. We
a lot of experience.
Yeah, we crashed the car several times. I didn't expect that, and we recovered several times. That's pretty good.
It's not about how many times you fail; it's about how many times you continue with your conquest.
Okay.
Are you saying like isn't it like about
That's Rocky.
Rocky, yeah.
It's about how much you can get hit and get back up, something like that.
Yeah, something like that.
Yeah. So yeah, Stallone said it right.
Yeah.
So yeah, that's it. So from Rick and me and I, Pedro, that's it for today. So I'll see you guys next week.
Yeah. See you
later.